Hey everybody, this is Larry. This is day 30 of the last day of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest, or this video, everything in between. We'll keep on going, alright? The streak is at 1490. We'll probably get it to 1500 and then see what happens. But, May is there, so come join us, hit the subscribe button, hit all the buttons. My other channel, the video, I'm gonna push it to tomorrow because mostly I didn't finish it. Because usually I do my videos on Sundays, and of course this Sunday I did a half marathon today. I was just so tired, and I barely got my workout in today. In case you're wondering, the day after the half marathon, I'm also rubbing my face a lot. You can tell, and I'm sniffing a lot because I don't know. I have a lot of allergies. Not a lot, but the same allergy, a lot of it. I've been taking everything, it doesn't seem to help, so I'm just like crying here, man. But yeah, so today I went to the gym and just messed around. Didn't have that much energy. I just did like 5 sets of squats, 5 sets of bench, just like some dumbbells, and mostly a lot of stretching as well, to kind of, because I think I been a little bit lazy on the stretching the last week. Now that the race is over, I can kind of focus on that again and try to gain a little bit of weight, bulk up a little bit. But all right, let's take a look at today's problem. 1915, number 1, devote substrings. I'm gonna do another. Sorry, I'm getting allergies. Oh my man. But yeah, I'll do another video after this for another problem. So definitely check that out if you thought this one was too easy or you just want to do another one with Larry. All right. A winnable string is a string that has where at most one letter appear an odd number of times. For example, CCJJC, and I think there was another problem. I don't know if I've done this one anyway, but there was another one where they called it like almost palindrome or something, but I don't know, it doesn't really matter. But anyway, given a string word and the first consists of first 10 lowercase English letters, A to J, return the number of wonderful non-empty substring in word. If okay. N is 10 to the 5th. I don't know why. Does that A to J really matter? I guess so. I mean, I guess the size of the alphabet. I mean, they could just use. Okay, fine. I mean, the size of the alphabet. But basically now, we're trying to get the count of things, right? There are probably a couple of ways to think about this. I'm going to try to think real quick. One is maybe we could do something on the length, right? But given that n is 10 to the 5th, anything else, n times n is probably going to be too slow. So you want to at most do something like n log n, right? But yeah. One thing that I've been talking about, of course, is contributions a couple of times, and also sliding window. So sliding window, maybe we can do it this way. I don't know. But it's a little bit awkward. No, I mean, I think there are other ways to do it, right? But I think this is actually a dynamic programming problem. I think that's not so bad. I think the key thing is noting that there are only 10 of these, and that makes it like a dimension that you can abuse, right? Because then now the size of the alphabet, if you will, is going to be 10, which is a little bit smaller. I don't think it matters that much, or like they could have just chose a slightly smaller n, really. But you could do something like n times alpha maybe, and that may be fast enough. The idea here then, right, is okay. Let's start by saying, sorry, allergies. Yeah, I guess there's a couple of ways you can do it, but okay. So basically, okay, let's start from the beginning, right? Let's say if we, for the sake of learning, let's say we just ignore the odd part, right? Meaning that okay, a wonderful string is a string where everything is even characters, right? Even number of characters. So what does that mean? That means that now we can play around with it, right? That means of, let's say, prefix sum, right? So let's say we have prefix sum, and the idea here with the prefix sum is that we just keep track of the number of A's, B's, C, D, E, F, G, I guess up to J or whatever it is, yeah, right? Then what happens, right? So then now, let's say we have, I don't know, these are not interesting enough of examples, but I'm just, okay. Let me add some C's and B's, right? And the idea with prefix sum is that at any given point, okay, so let's say, we start with 1A. I don't have a great way of visualizing it. I know what I want to say, but yeah, like, we start after the first characters, there's going to be 1A. After the second character, there's 1A, 1C. After the third character, there's 2A, 1C. And then 2A, 1B, 1C, right? And then maybe 2A, 2B, 2C, or 1C, sorry. And so forth, right? What does this mean? This means that here, for every part of this, if we only do evens, then now one way you can think about doing this is that we just do lookups, right? And what do you mean by lookups? Here, let's say we're checking it for this character, right? Or we're at, we have a pointer here, this is the index or something like this, right? This is kind of a hard problem for Medium, to be honest. I know how to, but it's still, I feel like it's not that easy, unless there's a really easy way of doing it, which I'm missing, but nonetheless. But one way that you can think about this in a brute force kind of way is that you go, okay, well, one even number of A's, that means that we now have 0 A's. 3B, 1C is good, right? Because we're looking for this in the previous scene before, because in a prefix some kind of way, if we see this, that means that the difference between this and this is going to be 2A, right? Because you can think about it as just this number, or not this number, but this set, if you will, subtract this set. If you subtract them, you get 2A, right? So that means that two indexes, between those two indexes, there's 2A. And then, of course, there are other possibilities that you can look for here, right? Because then now you can say, okay, maybe we want 2A, 2Bs. Then now we have to look for previously seen 0A, 1B, 1C, for example, right? Because this subtract from this will give you 2A, 2B, which is a wonderful string because now it has two of every character, or even number of every character, right? And of course, let's just make something up, and let's say this is 5. Of course, you also want to look up, well, okay, let's just keep it even for now. Right, now you also look for, in this case, you have to do a lot of possibilities, right? Because you have to look for 2A, 3B, 1C, because then that means that there's 4A differences, and so forth, right? ... So there are a lot of possibilities. It's not really feasible to do it that way. However, one thing to kind of improve on this, instead of doing every possibility, what is a thing that we notice? The thing that we notice is that here you have 0, you have 2, you have 4, but they're all even numbers, and this is an even number. So another way to phrase it is that, well, I have an even number. What subtract from this number will give me another even number? Well, a even number minus a even number gives me a even number. And so now then you can maybe, instead of phrasing it like this in a prefix some kind of way, you can say, so instead of looking for seeing this in the past, for example, let's say, just to be clear, I don't think I made it too clear, I don't know. Let's say like before this, like, we were here before, let's say, okay, so let's say this is the prefix, and then we have AA, right? So then at this point, this is going to have 6A, 3B, 1C. So we look for 2A, 3B, 1C. Then now we can subtract this from the whole string, which gives you 4a, which is the even number of things. So in this way, it's kind of like a prefix sum kind of way, right? But as I said, now you can just narrow it down to even numbers, because then now we can rephrase this as odd a's, odd a, odd c, even a, odd c, even a, odd b, odd c, even a, b, odd c, right? And so forth. Even a, odd b, c, right? And then now here, we still keeping track. We have 6a, 3b, 1c. And now what do we look for? We're looking for even a's, odd b's, and odd c's, right? So that means that, and here we've seen it twice. Yeah. Which you can kind of, that means that here, if we're at this point at the last index of the string, that means that there are 2 places in which we can choose the starting location, the left pointer, and still end up with it being all even. And as it turns out, one of them is here, right? 4a's makes sense. Actually, there's another one with 2a. We just kind of cut it off. But and 2b's, right? And it's not just 2b's, but it's, 4a's and 2b's, but yeah. So that's basically the idea, is to keep track of the number of each character and then do a lookup on all this, right? So let's do it this way. Right? Jeez. And that will give you the number of even things, right? So then now, sorry, I think I forgot a point, which is the odd part. Okay, but now the wonderful string, now we go back and say, okay, one letter may appear odd number of times. What does that mean? Well, we only have 10 letters, so the thing we can do is just we brute force the odd character, right? So let's say in this case we have 3 characters. Let's say we want to brute force B. What does that mean? That means that if B is the odd number, then here now we have to flip it. So then now instead of looking for an odd B, we also look for a even B, which we actually have here. And of course, this actually corresponds to this location, which has an odd B, right? So that's basically the idea. And yeah, and that's good enough for us to start building, right? So for C in Word, and I'm going to do it in a very the reason why I'm like is because I think the way to basically TLDR is that you want to do with bit masks, but the reason is because it's just a very compact thing to do. But yeah, so let's do it that way, right? So what is a bit mask? This is a very quick intro. It's not supposed to be exhaustive, but basically here now as we said, we want to keep whether, before A, B, C, D, E, F, G, H, I, J, we want to keep whether they're odd or not, right? So maybe you can say, is odd, it's a variable, is you go to force, dot, right? Or put it another way, of course, it's just force times 10, right? I think it's 10. Right? A, B, C, D, E, F, G, H, I, J. Yeah, 10. I thought I read somewhere saying 10, but... Oh, yeah, here. Okay. Right? And of course, another way to represent this, of course, is that if you kind of write this out, it's just like FF, right? 10 of these. And another way to think about this, though, is that the F is correspond to zeros, and T being true is you go to ones. Then now this is just all zeros. And of course, if you have ones, they would just have random ones somewhere, right? And this just represents whether the character is being used. So basically, another way to think about this is, yeah. But for now, I'm going to do bitmask in a weird way if you already know bitmask. But this is meant to be as a teaching kind of thing. So, definitely optimize it later if you like. But yeah, okay, so for C in Word, we want to convert it from, C is a character from A to J. So we want to convert it from that to 1 to 10 or 0 to 9. So we convert this by doing this. right? And then so now let's say D for digit, right? And then now is odd sub D is equal to not is odd, and because if it was odd, then it's not odd anymore. If it's even, it's not even anymore, right? So that's basically what this is saying, right? Also, let's do total 0, 0. That's just for an answer. And then now we could say total we added by count of is odd. Maybe. I don't know. No. What I want to call it. Basically, now we want, given is odd, we want to see how many times the even thing has happened before, and here we can say, yeah, allergies is kicking my butt today. Yeah, just count, right? And here we can count by having a frequency table, right? And the idea is just, well, now we want to convert this to a number, just for, as we said, we have all these F's and T's. We want to convert it to zeros and ones. So yeah, so then now we can yeah, or right. So now for I in range of length of is odd, which is 10, I suppose, right? And now we start with a binary number. Sorry, allergies is kicking my butt. With shift and add, right? So you shift times it by 2. We added to int of is odd of I, right? Meaning that if it's 1, or maybe you can write it as if it's odd of I, then we increment by 1, and then that's it, right? Otherwise, you add it by 0, but no, this is to get the bit, you don't return it. And then now we return f of the b, because that's just how many times we've seen it before, right? Because the idea about this is parity between odd and even, and that's how you get it. Okay, so this is good for getting all characters even number of times, right? I'm actually, yeah, okay. Yeah, maybe I'll do a converter thing. And then just right here. Right. But now we have to brute force the odd one, but we only have 10, so that's fine, right? So for range 10, we go is odd sub I is equal to not is odd. So we flip the bit, we add the count, and then we flip it back. Remember, flip responsibly and flip it back when you're done, right? And that's pretty much it. Unless I messed up, which is also totally true. Oh, no, it's not done because. And then now the last thing to do is now that we're back to is odd, we should add it to the counter of the times that we've seen before. So we can just do f of convert is odd, remember by 1, and we should be done. We should be, but we're not. That's odd. Get it? Sorry, my allergies are just really bugging me. All right, let's see real quick. Maybe I missed something silly. Okay. So how do you get 2? Oh, I guess this is it. Yeah. I'm not even printing correctly, Larry. All right. 0, 1, 2. 8 should be good. Oh. This is just me being silly for at least one thing anyway, which is that we have to put 0 as, or for prefix sum we have to do zeros as one entry, so that basically you're creating you're creating the beginning of the thing as one thing, meaning that, for example, if you have, I'm just being, like the thing that we had before with, you know, a lot of whatever, you have to be able to, basically we have to set the thing for this thing, which is the beginning, right? And the beginning, you have one place to end. So that's why I had to do it this way. But yeah, but I just kind of, man, forgot. Too much explanation. Too much explaining, not enough doing. But yeah, that should be good. Not gonna lie, this may time out because we didn't use bitmask, but yeah, that's fine. But yeah, but that's the idea, right? So this is the core idea behind the problem. The reason why this times out is kind of a little bit crappy, but it's fine, which is because we didn't use bitmask. The reason why we want to use bitmask is because of this reason, is that it's efficient. The idea is that instead of using a Boolean array and then you convert it to a way to hash it, if you will, into a count every time, you can just do it with the bitwise thing, right? So then now it's odd, we just set to 0, which is in a way 10 zeros, and then we don't have to do this anymore, right? I mean, I just kind of did all the other stuff for illustration purposes, but yeah. And then you can see that the only thing that's different is that obviously this is not an array anymore, so you would do something like this, which does the same thing. Oops. Which does the same thing. I guess the count thing is no longer useful, so I just put it this way, right? And then the same thing here is that we're trying to be responsible, so we can just do for the odd thing. And then flip it back. Give it a submit again. But yeah, as you can see from the bitmask, it's just it's just a very minor thing, right? Like, you know, we basically didn't really change the code that much, except for removing some helper functions. But yeah, so what's the complexity here? It's pretty straightforward in a way, because it's just the two for loops, right? This is character, the number n, where n is the number of words in characters in the word, and O of 10, which is, maybe I should put this in a constant, but it is just the number of the size of the alphabet, which is from A to J. Allergies is kicking my butt today. So yeah, it's from A to J. So yeah, that's pretty much it, right? You can kind of see all the other things. All these are kind of O of 1, if you want to call it that. I don't know, depending on context. But yeah, that's all I have for this one. Let me know what you think. And yeah, that's all I have. I'm just kicking I can't even think anymore. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.